Welcome back. What I would like to do is continue our conversation about talking about application problems or word problems dealing with quadratic equations. And the fifth problem that I would like to take a look at is below. The sun casts a shadow from a flagpole. The height of the flagpole is 3 times the length of its shadow. The distance between the end of the shadow and the top of the flagpole is 20 feet. Find the length of the shadow and the length of the flagpole round to the nearest tenth of a foot. That's a lot of information, isn't it? So let's try this again. So we have a flagpole. I'm going to draw a picture. So here's our flagpole. Let me try this again. There's our flagpole, okay? And the sun casts a shadow from a flagpole. The height of the flagpole is 3 times the length of its shadow, okay? So we have a shadow. Let's just put it down here. Okay, and the so again, you picture the sun back here casting a shadow. All right, so the height of the flagpole is 3 times the length of its shadow. The distance between the end of the shadow and the top of the flagpole is 20 feet. Okay, so this is the end of the shadow down here, and the top of the flagpole, that's 20 feet. Okay. Find the length of the shadow and the length of the flagpole round to the nearest tenth of a foot. So I don't have this completely labeled right. One more time. The height of the flagpole is 3 times the length of the shadow. So the length of the shadow, we've got to call it something. I'm going to call it x. And it says the height is 3 times this length. So this is 3x. Again, it's all about labeling this stuff, so make sure you're comfortable with that. Okay. Now it wants to know, what does it want to know? Find the length of the shadow and the height of the flagpole. We can do that. Now the relationship we have to use here is the Pythagorean Theorem. Y'all know it. If you have a right triangle, then a squared plus b squared is equal to c squared. Okay. Now our problem doesn't have an a, b, and c, but it does because your c is always the hypotenuse, the one that's across from your 90-degree angles. That's the 20 feet. Your a and b doesn't matter. So I'm just going to say a is across the bottom. So a in our picture is x squared plus b in our picture would be 3x squared. Notice the parentheses because you're squaring the 3 and the x. So 3x squared equals our c, again, the side across from the 90-degree angle is 20, and I'm going to square that as well. Now I need to simplify this. I've got x squared plus 3 squared is 9, x squared is x squared, and 20 squared is 400. And notice once again we have a quadratic equation. Our quadratic equation needs to be equal to 0. So what I'm going to do is I'm going to subtract 400 from each side of my equation, and that's going to give me x squared plus 9x squared minus 400. Which we could say, really, x squared plus 9x squared, y'all, is 10x squared minus 400 equals 0. Now, when you look at this, you've got options. You could attempt to factor it. I see a greatest common factor already. You could use the square root property, right? If you don't have an x term, which we don't have an x term at all, then you're allowed to use the square root property. Or you could use the quadratic formula where a is 10, b is 0 because it doesn't have a b, and c is negative 400. But I like the square root property. So here I go. I'm going to add that 400 back over because after realizing I could use the square root property, I need it back in the right format. There we go. I'm going to divide both sides by 10. That gives me x squared is equal to 40, and then I take the square root of both sides. So I have the square root of x squared is equal to the square root of 40. But remember, whenever you use the square root as a tool, you must put plus or minus in front of one of the sides, okay? Must, it's required. So I have x is equal to plus or minus the square root of 40. Now the square root of 40 will break down, right? There's a perfect square that divides into 40, and it is 4. So this is the square root of 4 times the square root of 10. I can simplify that further to say x is equal to plus or minus 2 square root of 10. Now, then you go back to look at what you just found. We found x. X is the length of our flagpole down here, the shadow of our flagpole. This is our shadow down here at the bottom. And that's x. Now, does negative 2 times the square root of 10 make any kind of sense for the length? And the answer is no. So the only appropriate answer for the length of our shadow is positive 2 square root of 10. Okay? So this is the shadow. That's how long the shadow is. It also wants to know how tall the flagpole is, and that's 3 times x. So the pole is equal to 3 times 2 square root of 10, which is equal to 6 square root of 10. Finally, it wants our answers rounded to the nearest tenth of a foot. So I'm going to type in the shadow, which is x, in my calculator, which is 2 square root of 10, and then round that to the tenths place. So 2 times the square root of 10 is equal to 6.32455, rounded to the tenths place is 6.3. So it's 6.3 feet. On the other hand, the pole, remember, was 3 times the shadow, or 3 times 6 square root of 10. 3 times 2 square root of 10, which is 6 square root of 10. I type that in my calculator. And I get 18.9736, but I have to round that to 19.0 feet because it wanted it to, again, the tenths place. And 18.97, the 9 rounds up and carries it over to the ones place. So in sentence form, I would say the shadow length is 6.3 feet and the length of the pole is 19.0 feet. Hey folks, I did notice that I skipped a problem from one video to another. So if you're wondering where this came from, flip back in your notes and you'll see if a triangle that has an area of 110 square feet has a height that is 2 feet less than twice the width, what are the dimensions? So let's try this problem. So I know I have a triangle, so I'm going to draw a triangle. I just draw a general triangle. I don't know if it's a right triangle, I don't know what. But we know that it has an area of 110 square feet. So remember, area is 110, and we also know the area of a triangle is 1/2 the base times the height. Okay, it says it has a height that is 2 feet less than twice the width. Okay, so they're calling their base W, and that's okay. So that's 110 is equal to 1/2 W times the height. Okay, our height, remember, is straight down. All right, and again, it says it has a height that is 2 feet less than twice the width. So this height, I'm going to come out here, is equal to 2 feet less than twice the width. Now, when you say something is less than something, that means you have to minus 2. So I have to do twice the width, and then I have to minus 2. Okay, so again, think about it. When you say something's less than, like if I say 5 less than 8, the answer's 3, because you do 8 minus 5. This is the same story. When you say less than something, that means you subtract that thing on the outside. So over here, I'm going to fill in my equation. I have 110 is equal to 1/2. Now the width, we're just going to call W, and the height, in terms of the width, is 2W minus 2. Okay? Now remember, I have a choice. I can multiply this 1/2 inside, and it wouldn't be bad if I did, because these are both even numbers, the 2W and the 2. Or I could make my life easy and just multiply both sides of this equation by 2, and boom, this fraction's gone. So now I have 220 is equal to, now I'm going to distribute this inside, 2W squared minus 2W. Notice I have a quadratic equation because of the square, which means I need to get this thing equal to 0 by subtracting 220 from both sides. I have 0 equals 2W squared minus 2W minus 220. Now, what I do know is the square root property doesn't work on this problem because I have this 2W right here in the center. I also see that I have a greatest common factor of 2. I could factor that out, or I could just jump right into the quadratic formula. I think I'm going to factor that out. got w squared minus w minus 110. So when I factor this, I'm trying to find numbers that multiply to equal negative 110 and add to equal negative 1. The numbers that might do that are a negative 11 and a positive 10. Well, check it. Multiply those together. That's definitely negative 110. Add those together. That's definitely negative 11. So this will factor into 2 times w minus 11 times w plus 10. I set each one of these factors separately equal to 0. Now I can't set the number 2 equal to 0, but I can set w minus 11 equal to 0 and w plus 10 equal to 0. I add 11 and add 11. I get w equals 11. I subtract 10, w equals negative 10. The question to you is, can width be negative 10? Absolutely not. So our width is 11, or we're talking about feet, so it would be 11 feet. And then to find the height, we would plug that 11 back in to 2 times 11 minus 2, which is 22 minus 2, which is 20 feet. So in sentence form, I would say the width of my triangle is 11 feet and the height of the triangle is 20 feet. Our sixth problem, the distance between opposite corners of a rectangular field is 4 more than the width of the field. The length of the field is twice its width. Find the distance between the opposite corners round to the nearest tenth. Okay, so first of all, let's draw a picture. We have a rectangular field. So there I go. Now it says the distance between opposite corners. Okay, so from this corner to this corner, and of course it's a rectangle, right? So it wouldn't matter which opposite corners we chose, it would be the same length. And it says is 4 more than the width of the field. So I need to label the width. I'm going to call this the width. And then 4 more than the width would be w plus 4. And that's often called a diagonal. So that diagonal is w plus 4. Notice it goes on to say the length of the field is twice the width. So the length across the bottom down here is twice the width, so 2w. And it says find the distance between the opposite corners. So we're trying to, in the end, we're trying to find this distance right here. Okay? Now, to do that, we're going to go back and use our Pythagorean Theorem. If you'll recall, side squared plus side squared equals the hypotenuse squared. So I'm going to say one of my sides is 2w. I need to square it. Plus my other side is w. I also need to square that. And the hypotenuse is always the one across the 90-degree angle, which is the corner of our rectangle. So that's going to be w plus 4 squared. Now I need to simplify this equation. So 2 and w squared is going to give me 4w squared plus w squared is equal to, and then on the other side, we're going to FOIL, or w plus 4 times w plus 4, which is going to give me w squared plus 4w plus 4w plus 16. Now I need to simplify this as much as possible. I'm going to add like terms on the left. It's going to give me 5w squared. On the right, I have w squared plus 8w plus 16. Notice again, we have a quadratic equation. How do I know? Because of the squares, right? So I need to get this thing equal to 0. All right, so I'm going to move everything to the left. The reason is because 5w squared is bigger than 1w squared. So I want to keep my w squared positive. So minus w squared minus w squared. I'm also going to subtract 8w and subtract 16. That's going to give me 4w squared. Move the 8w to the other side, minus 8w. Move the 16 to the other side, minus 16 equals 0. All right. I could factor out that leading coefficient of 4 because it's greatest common factor. See that? I divided each of those by 4, pulled it out front. Now I'm trying to find numbers that multiply to be negative 4 and add to be negative 2, which is actually not possible. That means I need to use the quadratic formula. So it's going to be W equals negative B plus or minus the square root of B squared minus 4AC all divided by 2A. My A is 1, my B is negative 2, and my C is negative 4. This 4 that we factored out front, we don't have to use that. Now, if you wanted to do it back here with your A is 4, your B is negative 8, and your C is negative 16, you would still get the right answer. You would just have more simplifying to do. So I like to work with the smaller numbers if I can. W equals, that's going to be negative of a negative 2 plus or minus the square root of negative 2 squared minus 4 times A, which is 1, times C, which is negative 4, and this is all divided by 2 times 1. If I keep going, it's 2 plus or minus the square root of 4. 4 times 1 times 4 is 16. The negative times the negative makes that plus 16, all divided by 2. Moving to the right, it's 2 plus or minus the square root of 20 divided by 2. We know we can break down the square root of 20, so it's 2 plus or minus, that's 2 square root of 5 divided by 2. And then I can simplify this by dividing 2 into all three of those terms, which is going to give me 1 plus or minus the square root of 5. Now here's the deal. 1 plus the square root of 5 is a positive number. 1 minus the square root of 5 is a negative number, and we're talking about, again, the length of a side, the width right here. So that's not possible. So to find the width, I'd plug 1 plus the square root of 5 in my calculator, and I get 3.236. It says round to the nearest tenth, so 3.2. But notice it wanted the length of the diagonal. So the answer we'd have to plug it into W plus 4 would equal to 3.2 plus 4, so 7.2, and what is this in? We don't know. It's just 7.2 is from corner to corner. I don't know if it's feet or inches or anything. Okay, so 7.2 is from the distance from corner to corner of our rectangle. All right, the length of a 200 square foot rectangular vegetable garden is 4 feet less than twice the width. Find the length and the width of the garden round to the nearest tenth of a foot. So once again, we have a rectangle. It says the length of the rectangle, length of a 200 square foot rectangular, okay, so the area is 200 feet squared. So the length of a 200 square foot rectangular vegetable garden, yes, that's the area, is 4 feet less than twice the width. So if this is the width, the length is 4 feet less than that. Remember we talked about less than earlier. So you have to minus 4 to get 4 feet less than something, and it's less than twice the width. All right? Now we're supposed to find the length and the width of the garden. We know the area is 200 feet squared. Now you know area of a rectangle is length times width, right? So then I plug in everything I know. Area is 200. Length is 2W minus 4. And width we just call W. So notice once again I have only W's as my variable. So now I go on to 200. I simplify by distributing. This is 2W squared minus 4W. To keep simplifying, I need to get this equal to 0. Why? Well, because it's quadratic, right? It's an x squared, so I must get this equal to 0. I'm going to subtract 200 from both sides of the equation. So I have 0 is equal to 2W squared minus 4W minus 200. I keep going. 0 equals, now notice there's a greatest common factor of 2. I'm going to factor that out. 2, that's W squared minus 2W minus 100. Okay, so now if I were to factor this, I'd have to find numbers that multiply to be negative 100 and add to be negative 2. And my quick scan of numbers tells me I can't think of anything that does that. So what do? Use the quadratic formula. W equals, and notice my A is 1, my B is negative 2, negative 2. And my c is negative 100. So here we go. Negative of a negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c. And this is all divided by 2 times a, which is 1. I continue on to say 2 plus or minus the square root of 4. And then negative 4 times positive 1 times negative 100 is plus 400 over 2. Continue to the right. 2 plus or minus the square root of 404 over 2. Now listen, I could attempt to simplify this, but fact is they want our answer rounded, so it's time to plug into the calculator. So I know the plus one is going to be, see, 2 plus the square root of 404 divided by 2. Let's calculate that. Okay, I got 11.049, so that would be approximately 11. Whereas when I calculate 2 minus the square root of 404, I get a negative. So the minus one, this one, is out because we're talking about, again, the length of a side. So it asked for the length and the width. If the, remember this is W, if the width is about 11, then the length is going to be 2 times 11 minus 4. 2 times 11 is 22 minus 4 is 18. And we were talking about feet. So the width is about 11 feet. And I should just put 11.0 feet. And the length is about 18.0 feet. Okay?